This is question 7 in the Pearson Edexcel Pure AS Year 1 textbook, and it's exercise 12I. I've got the question on the screen for us here. So first it's asking us to find the coordinates of the stationary points. Stationary points is where the gradient is 0. If you think about a minimum point or a maximum point of a graph, if you do a tangent to that, it would be a flat line, so the gradient is 0. So first of all, I'm going to differentiate. So that's going to be 4x to the power of 3 plus 9x squared minus 10x minus 3. Then need to solve this. It's a cubic, so it's not going to be the easiest factorization. You can use the factor theorem for this. In my mind, the factor theorem is just let's just plug some numbers in until we get this to equal to 0, because that's what solving it does. My first number I tried was 1, so let's try x equals 1. So we've got 4x cubed, which will just be 4 if it's x is 1, plus 9 minus 10 minus 3, and that does equal 0. So x equals 1 is a solution. So I know one of my brackets to this is going to be x minus 1, because if we, you know that if we solve that, we would get x equals 1. You can then do some division by polynomials. I don't like doing that. I just like to do by inspection. I think it's a lot faster, and it's kind of a method we should be learning. So I'll walk you through the steps of how I would do this in my head. So x times by something here is going to give me 4x cubed. So I know that that's going to be 4x squared. Then I need to think, well, how many x squareds am I going to get from this term? I'm going to do minus 1 times 4x squared. So at the moment, I'm going to have minus 4x squared. So I need a certain amount of x here that's going to multiply with this term to make that into positive 9x squared. So I've got minus 4x, I need positive 13. So if I call this plus 13x, then I can just double check. That would give me 13x squared. Subtract 4x squared. Yep, I get my 9x squared. Final step, well, we know we're just going to have a constant at the end, and 1 times by something is going to get me minus 3. So that should just be a plus 3 at the end. You can always just go back and expand this and make sure you're getting the right stuff. I'll check I get my x terms though. So positive 3x and minus 13x. That gives me minus 10x. So I know I've factorized that properly. So x minus 1, then when I go to factorize this, I am going to get 4x minus 1 and x plus 3. So then my x values for the stationary points are 1, a quarter, and minus 3. To get the y values, I'm going to substitute it back into this in the original equation. Nope, sorry. Even higher up, I'm going to substitute it back into the original equation to get my y values. So when I do that, I'm going to get y values that correspond like this. Minus 3, 357 over 256, which is roughly 1.3, and y equals to minus 35, so I'll put a box around all of them. I now need to determine the nature of these. You can do that by checking just either side. So I could check for this one 0.9 and 1.1 and see how my gradients go. I could check just past a quarter of this. Sorry, here my factorization would be positive 1 there. And so this would turn into a negative a quarter. I could check things just either side. What I'm actually going to do, because I've got 3 of them to do and I don't want to do 6 different things, I'm going to find my second derivative. So my second derivative is going to be 12x squared plus 18x minus 10. And I'm going to substitute in the x value of these each. So x equals to 1. I'm going to get a value for f dash dash of x of 20. Therefore, that is a min point. This one here. Min. I know that because when I've got a positive second derivative, that shows how the gradient is changing. So the gradient's changing in a positive way. So if it's changing in a positive way, you're going to be starting off going negative, and you're going to get less and less and less negative because your gradient's increasing. So at this stage it might be like minus 8, then at this stage it might be like minus 4, and then it goes to minus 1, and then it goes to 0, and then it's going to 1, 4, 8. So we can see that it's increasing. So if the second derivative is positive, then it's a minimum point. And kind of conversely, if this is negative, then it's a maximum point for the same reasoning but the other way around. So you start off positive, then you get to 0, then you get negative, and your gradient, the value of your gradient, is actually just decreasing if you look at it kind of on a number line way, like I've drawn some numbers on there. Okay, so let me check the other ones. If I check x is minus a quarter, for that one I am going to get minus 13.75, so that's a max point. So I'm going to write that on there as well, max. And then I'm going to check my final one, so x equals minus 3, and I'm going to get 44. So therefore, a min point, if you got this to be 0, you would have to go back and check either side of it because this wouldn't tell you anything. You'd have to check back and do it the other way of checking just either side and spotting it from there. But this way's quicker. If you can remember, positive means minimum point and negative means maximum point. If not, that other way always works nicely anyway. Part B, asking us to sketch this graph. So I'm going to scroll down a little bit and we're going to see if we can sketch this. We've got quite a lot of information for this. Draw yourself a, this is going to be pretty terrible to be honest, but just draw yourself an axis. We've got our minimum and maximum points, so we've got a minimum point at 1, minus 3. 1 minus 3, we know that's a minimum point. We've got a maximum point at negative a quarter, somewhere like that. So negative a quarter, and I'm going to put 1.3 there just because I don't want to write that fraction again. We know that's a max. And we've got a minimum point at negative 3, minus 35. My scale's completely off. But for the sake of this, I don't think it particularly matters. As long as you get them in the right quadrants, you'll be fine. So we know that this is a minimum point, so it's not going to come through the graph like this. It's going to come down and then back up. And we know that's a maximum point, so it's going to come up and then back down. And we know this is a minimum point, so it's not going to keep doing this. It's going to come back up and go like that. There we go. So that is my graph. It's not particularly asked you to find any of the intercepts. You could find the y-intercept pretty easily, but we're not so fussed about the x-intercepts, just the minimum, just the stationary points in this case. Okay. And that is that question.